Welcome to Managing Your Serverless Servers, where I fit the word server as many times as I could into a sentence, which is not true. I could fit it in a couple more times, but it wouldn't fit on the slide. Where we're going to be talking about configuring the Faas, which, as we have discovered, even though we know it's a service-based framework, deep down, everyone thinks about the Faas. There we go. So my name is Amy Arambulo Negrette. I built a lot of serverless applications and workloads. But in general, I've been building for over 10 years. I used to do LAMP stuff, but now I do serverless stuff. And now I do it over at Track 10. They do migrations, I think, but I've only started 2 weeks ago. So we'll figure it out together. My favorite thing when you talk to anyone about serverless is, but where are the servers? Because it is a computer on the internet, so of course there's a server, and even if you at ServerlessConf last fall, it was still a really big issue, and I don't know why we still like talking about it, but we love to argue about it just all the time because, God, developers love to argue about stuff. So the big question is, where are they? Where are the servers? When we talk about serverless workloads, what are the things that are actually doing the work? The short version is in the cloud, and that can mean anything. But when a developer talks about what a server is within a serverless context, we're talking about where's the place that our code lives so that we can actually do the thing that we expect the computer to do. So taken from Linda's slide from ServerlessConf 2 years ago, the definition of a Faas is that it has to be stateless and ephemeral. I can't say that word. And it runs in fully managed containers. So instead of just pulling that slide up again, I chose my favorite type of container, and that's the kind of container that brings the same kind of food that just keeps bringing you more of the same kind of food as you need it, because I am always hungry. The way it actually works, and I use the heavy quotation marks on that because obviously every provider is going to do it in their own way and use their own terms, even though all the words are the same, they seem to mean different depending on who you talk to. So you get your code, you build your little Python hello world, let's print out a thing and let's go count some stuff. And then it gets built into a container image when you hit save, or it auto-saves because the cloud doesn't trust you either. And when you call that code the first time, it spins that up into a fully managed container that is going to be managed by the cloud provider. And every time you call it after that, it just spins up more images of that one image. And then once everything's done, they all die. Fingers crossed. So the short version of the where's the servers in serverless is that the container is your server. But that also means that it's not your computer. It's that old joke where it's just running on someone else's computer. That someone else is going to be the provider. So Amazon's controlling your server, Google's controlling your server, Microsoft is controlling your server. Which means when they build a server, they're going to build it what they think their customers need. It may not be what you need. What about my needs? I need this one library. I needed to be able to encrypt. I needed to be able to run this one security library that is the only security library that my company trusts. It's not what anybody else trusts, but my company trusts it, so I need it to run the way I expect. The short way of doing this is that every one of these containers have a way to modify the configuration settings to a point. And these are small things like bringing in easy libraries, and being able to modify things like timeouts, memory, stuff like that. So when you run into very specific overrun errors, it's very important for you to actually know what these limits are. In AWS, which is a cloud I use most of the time, they have a 50-minute time limit on lambdas, which is great if you're doing internal business, like you're doing ETL pipelines where you're grabbing from Athena, putting it somewhere else. It's great for that. It is not so great if you're trying to do that thing when attached to a gateway, because they don't want your endpoints to crash or timeout, so they forcibly put in a 30-second, which is a far cry away from 15 minutes. And they don't actually tell you what that difference is. So API gateway, if it's attached to anything, that new thing becomes a 30-second timeout. So you kind of have to know that. If you don't know that, you can keep changing the timeouts all you want on your lambdas, but if it's going to die in 30 seconds, you have 5 minutes and a half where it's not going to do much of anything. It also helps to know the defaults, because those defaults aren't 30 seconds or 15 minutes because they don't want you to default at the highest rate. Their default for one of those services was at 1.6 seconds. 6 is not a number that comes to mind easily. So I'm not going to guess it's going to run in 6 seconds. So that is an important thing to figure out, because if you're going to check against these limits, you really want to be super careful about what they actually are. And finally, monitor your logs, which seems like a no-brainer, except all of these logs pipe to different places and get connected in different ways and are not always connected by default. So you can say, yeah, I'm going to check this timeout, except you can't check a timeout because by the time the container dies, it's died, so it's not going to print I've died in the log. It's just going to say, hey, it ran for 14 and 59 seconds. We don't know what happened. It's like, well, you kind of do. But if you know along this can solve a lot of your prototyping questions right off the bat. It saves you a lot of time, a lot of cost, and you don't slam your face into your desk nearly as much as I do. But like I said, extra libraries. Those things that we assume when we build on a monolith, it's like, yeah, we can just pump this thing full of libraries. At worst, we're going to ask IT for another hard drive. It's not going to be a big deal. You can include it as part of your deployment package. If it's the kind of library where it's just going to check the paths of stuff, then you can do that, and then that's easy, and then you can go on the rest of your day. But you do have to check against the size of those deployment packages because, again, they differ between clouds, and you have to make sure that library has its dependencies of its own, and you have to include those because you can't trust that they're going to be contained within the default container either. And on AWS, specifically to resolve this problem, they have layers, which whenever I bring up this problem, they go, why don't you just use layers? And it's because I'm going to get errors. I'm going to show you in a minute, and you're not going to give me a solution for that. So the point of a layer is to create a shareable library that still counts against your deployment size. And you can only have 5 of them. So you can kind of have to bundle all of your libraries into a single layer. And if it still counts against your deployment size, it's not really shareable at this point anymore. So it doesn't really help very much. Unless you have one of those companies, you have all of your internal libraries in one place. But they also checked everything, so kind of give and take. So for some reason, the cloud makes us use YAML. What Lambda doesn't do is include YAML. So you can't parse it by default because that's a decision that makes sense. But it's okay because I built a layer for it. It's super easy. All you do is build your deployment package, which is a long process of building a Python. You install it through pip, and then you have to match the pathing, and then you have to make sure that pathing matches the container or whatever. But if you get all of that in a proper zip file and everything's properly formatted and nothing errors out because they never do, you can create your layer. All you do is upload it, and it puts it in the thing, and it has to do the dropout. No problem, because YAML is super easy. And if you run it, I have a nice little Lambda code here. It's whenever it runs, it prints out my contact information because that's how you do embedded promos. But yes, so you drop it down, it goes into there, you run in the code, and it's all fine. It's fine. Of course, I'm just converting JSON to YAML. That shouldn't be a problem, but what happens if you need something that actually does work? like an SSH library. Paramiko is a pretty standard library for that, especially in Python. Assume only in Python, but it requires a lot of stuff because it requires encryption libraries, and it has those SSH client things, and it gets super complicated on the inside of it, even if it is just a wrapper for Python SSH. So you build your super long zip file, and I don't have the contents of the zip file on this slide, but trust me, all of the dependents I should have had were supposed to be there. And you add that layer to Lambda. But remember, this is not my computer. This is Amazon's computer. I'm trusting them to give me what I need. And then I get attacked by this elf error. It says elf error. It doesn't explain what an elf is, so when you Google stuff, if you Google elf attack, surprisingly, one of the images that will come up for this error is actually going to be one of my slides with Drist on it, because apparently a lot of my slides have Drist on it. So why not? So the short version is, up there it says, unable to import module because of this invalid elf header. Doesn't really explain what's invalid or why it's invalid. So the basics is that elf is a binary file. It has all of the stuff that these libraries are built on. It's generally included as part of your Linux kernel download, I don't know. And usually, if you put it into a container or a Faas and you build it that way, it would be contained in your default container, except on Amazon, because it's not. This is just the Wikipedia definition of what an elf is. It's just an executable file. So the error occurs because it's looking for something that's not there. In my case, in my case, it's the bcrypt library, which is a standard encryption library for Python on the default container for Python. It is not in the Amazon Linux AMI. So you're not going to get that, and you're going to run into that error. And if you try to figure out how to work around this error, the internet is going to tell you to build another container, which makes sense. Why can't we just bring our own containers? So we're going to bring our own containers, because we can't, as much as we tell Amazon what we want, we also cannot wait for them to actually give us what we want. We have to wait for December when they give it to us as a surprise. So when we're missing dependencies, we have to create a custom container just to run the things that we think should be running anyway. Since providers run their own containers, they want things that is lightweight for them, that they can use, and that they have already optimized. To make sure what you need is there, you have to modify that image. And the only way to modify it is to remove one of the advantages of serverless, and that's having a fully managed service. So now, if you do it and you make your own container image, you have to make sure your container is also updated. Now it's now your responsibility. So I just realized I missed a slide, but the end of that story is that when you do this, the new container, using whatever Docker image you put together, will end up spinning out instead of the default Amazon one. And then it will work. And then and if it will work for one library, you can also include whatever business libraries you require, and you can basically bootstrap the way we would on a LAMP stack, but just have it spin up and spin down, and we just don't have to pay for those libraries to hang out. There is another solution, though. Maybe this is not good enough for your security council. Whatever security team you have, because it's almost always them complaining about it, that since they cannot control the infrastructure, they can't ensure your environment is secure, even though there are 20,000 white papers on this subject. But we don't have time for that. It doesn't fit our one particular checklist, so we're not going to deal with it. So fine. So how much money are you willing to throw at the problem? A lot? Well, good. So there is a way to create serverless-like behavior in things that are not necessarily a serverless platform. And it's basically bring your own cloud function platform. And this works very well if you have customers who are still working applications on-prem, or they had bought their data center space, and they own that property for the next 30 years, and they just want to use that space for something. So you can actually do it this way. You can just, and this way, there we go, is using a custom Faas solution. There's this, which is Apache OpenWhisk, which is a very good service where you can take your own containers, your own messaging, and if you want to control everything from end to end, which again, two of the things you lose is the optimization, and you're now losing cost the cost optimization, because now it's up to you to make sure you have a guy who knows how to do all of this. This is now a full-time job for someone. Do not make your developers do it. Then they become infrastructure engineers and they quit. But you can actually create your own solution where you do control all of your endpoints. And if you want to make sure this stuff never touches the internet, this is probably the safest way of doing it. If you want something that's a little of both, I want my peanut butter with my chocolate, what you can do is actually use Kubernetes, which is a word that I hope no one outside heard me, because then they would rush in here and then take me off the stage. So there are a lot of Kubernetes solutions that are fully managed to the point that you can actually kind of backdoor serverless solution into them. Azure has one called Kata, AWS has Fargate, and Google just really loves Kubernetes, so meh. But there are ways. So if you use a Kubernetes solution, you can control it so that everything does die when everything's complete. Everything does spin up, only you do horizontal spread instead of vertical, then you can do that. And you can also, but this way you control your containers, you control your timeouts, you control your memory usage. And if you have a larger company that's really picking on costs, or that is the way or efficiencies is the way your company makes money, that is one of the possibilities, especially if you're already embedded into the cloud. Also, if you use a Kubernetes-based solution, that whole vendor lock-in argument goes away, because you can just take those containers and drop it into your competitor's Kubernetes platform and do literally the same thing. And this way, if you have, and this is one thing I really liked about the keynote, if you have PHP, you can use PHP. And I like the fact that I heard someone say PHP before Python and Node, and that makes me, in my old LambStack heart, very happy. And since you're the one controlling the containers and security for some reason trust Kubernetes more than general cloud, they are more likely to be able to do a positive security audit of your containers if they're allowed to manage what those containers actually are. And let's face it, at the end of the day, application engineers don't really want to deal what's inside it anyway. So it may be the one solution that only pleases everyone a little bit. Wrong bit. So I know I spoke a little quickly. I didn't, surprising. We did go over how a Faas works, kind of, sort of, where it's a container and it makes a bunch of other containers. And how to handle small configuration changes, very specifically, check your logs and check your limits. That will solve 60% of your problems. And then the other problems are, we didn't build this thing for the thing that we were going to put it in. Which leads to the next solution, which you can either use your own container and try to shoehorn it into the solution you have, Amazon, or you can use a Kubernetes solution that is in all cloud platforms to basically do the same thing. And also, if you want a fully end-to-end kind of process, you can do that too. Again, that is a cost that you have to be super conscious of taking on, because that is minimally one infrastructure guy full-time just to do that. And Infrastructure is hard for me, and infrastructure guys don't like doing that type of a job, so you're paying top dollar. And there we go. Okay, this should say thank you, but it doesn't. So thank you.